you today? I'm Nadia Saba, president and founder of Dr. Greenhouse. Today I'm going to be talking about the 7 reasons to have access to outside air for your indoor farm. You know, I get a lot of questions from growers and other engineers asking me, why would you want to introduce outside air and ventilate an indoor farm? Aren't you concerned about losing CO2 and disrupting the plant environment by having ventilation air and even possibly purging the room when you're enriching it with CO2? Although I totally understand the concerns around costs and around wasting CO2, there are also a lot of really good reasons why I think it's important to at least have access to outside air. The first reason is to meet minimum building code requirements for ventilation. Every jurisdiction, no matter where you are in the country or even in the world, has a minimum code requirement for ventilation that's based on either square footage of your building or room or the number of people that could occupy that space. Some people are getting exemptions depending on where they're located for actually providing this minimum amount of ventilation air to their indoor production facility. However, I always like to still include that in our load calculations, in our HVAC design, for a couple of reasons. And one of those reasons is to just allow the building inspector to check that little box that says they are meeting the minimum ventilation code requirements. So rather than trying to educate our plan check reviewer or the building inspector of why this space doesn't necessarily need fresh air to make plants to grow, it's just easier for me to provide that minimum ventilation rate and avoid having that conversation altogether. The second reason why it's a good idea to have access to outside air is if your CO2 enrichment system were to fail. And by fail, I mean fail open. So many jurisdictions, many fire marshals around the country are requiring indoor plant production facilities to have a CO2 emergency purge system. So in the event your CO2 enrichment system runs wild, right? You're trying to hit, say, 1,000 or 1,500 parts per million of CO2 concentration in your production room, and the solenoid valve stays open. Something goes wrong with the controls, and the CO2 just keeps pumping in the room to 2,000 parts per million, 3,000 parts per million, 5,000 parts per million, and there's no way to remove that CO2. It could eventually become dangerous or hazardous to your workers' health. So a CO2 purge system might start with alarms, audible and visible alarms, as well as, trying to automatically shut that solenoid valve closed. But in the event that the CO2 system keeps pumping CO2 into your room, you would want to have a way to remove that CO2 so that it doesn't reach those dangerous levels. Many jurisdictions require at about 5,000 parts per million to turn on this evacuation system, bring in fresh air, and then evacuate it with an independent exhaust system or even using your HVAC system. OSHA doesn't necessarily consider CO2 a toxin or a toxic gas. And at elevated CO2 levels, no one has ever died. However, our productivity and our mental capability do reduce dramatically at elevated CO2 levels, even as low as 700 or 800 parts per million. Therefore, having a way to remove that excess CO2 can be really good for your employee health. The third reason why you might want to have access to outside air is if your CO2 enrichment system fails closed. So what happens if your CO2 tank runs out of CO2? Or what happens if your solenoid valve stays shut and doesn't open when there's a call for CO2? Now your plants are going to be continuing to use CO2 as long as the lights are on, and they will remove that CO2 to levels that will be lower than even ambient. I've had clients who have said, Nadia, I don't really understand. We have all of our environmental parameters optimized. We have, the light levels perfect. We have the temperature perfect. The humidity is perfect. Our water temperature is perfect. Why won't our plants grow? And so we'll sit there and just kind of go through and troubleshoot, like, what is going on? And a couple of occasions it's dawned on me, and I'll ask the question, you are enriching with CO2, right? And you just hear this pause, this quiet on the other side of the phone. And they say, no. I say, and you have a sealed, closed air conditioning system? Well, yeah. Well, what's your CO2 level? They run into the farm, take a CO2 measurement, and realize that the CO2 levels are like 200 parts per million or lower. Well, they're literally starving their plants. They cannot photosynthesize if there is no CO2 in the room. So the question is, even if you have a CO2 enrichment system, if for some reason it isn't able to disperse CO2 in the room, do you have another source of CO2, aka the outside air? Even if we can control the levels of CO2 in your room to ambient outdoor levels, we won't be starving your plants. Sure, you might not get the maximum productivity that you were hoping for when you are able to, control to 1,000 or 1,500 parts per million, but it's a lot better than running your room down to 150 or 200 parts per million. So the fourth reason why you might want access to outside air is to temporarily ventilate your space for workers. Like I mentioned earlier, having elevated CO2 levels can actually decrease the performance of people and reduce people's physical and mental capabilities. So if there are periods of time during the day or during the crop cycle when people are, very active in the room, transplanting, harvesting, pruning, scouting, doing all the things that your workers and your staff do, if you could temporarily ventilate for just an hour or two while they're in there, you could actually increase the performance, increase the speed at which they do their job, and make a healthy environment for humans, for people, with a temporary reduction for plants. And again, plants will still photosynthesize. They might not photosynthesize as much or grow as quickly as under 1,000 or 1,500 parts per million, but you're not going to be starving them, and you're going to be helping your people work better. The fifth reason why you might want to have access to outside air is to flush the room. Again, another temporary reason to have outside air and to ventilate. If you are a grower that does chemical sprays or does washdowns between crop cycles, or even burns sulfur to push back powdery mildew, being able to ventilate and evacuate those chemicals, evacuate that sulfur from the room after it's done its job, will help you to maintain the environment you want the rest of the time. So again, it might only take 15 minutes to evacuate that room, but you're not leaving all that sulfur and all that chemical and all that moisture from those sprays in the space. The sixth reason why you might want to have access to the outside air is to quote unquote burp the room at night. So we know that plants use carbon dioxide for photosynthesis when the lights are on, but when the lights are off, plants actually switch to respiration. Actually, they're respiring when the lights are on as well, but when the lights are off, they don't need CO2 anymore, and in fact, use oxygen and generate CO2 for respiration to energize the plant and to use those carbohydrates to build to build themselves. So why would you keep CO2 in the room? Just like humans, if we have elevated CO2 during our respiration and it affects our productivity and performance, plants being exposed to high CO2 levels when they're also trying to respire can reduce their performance and reduce their growth. So being able to just flush the room of that CO2 when the lights turn off and then re-enrich when the lights turn back on can be very good for your plant productivity and health. The last and seventh reason why I would recommend access to outside air is to save energy. If you live in a climate that is cool and dry, you actually have the opportunity to use outside air to do your cooling and dehumidification rather than using the compressors required for air conditioning. This can be a huge energy savings by being able to not use those compressors. So yeah, okay, you might be rejecting carbon dioxide to the outside by using 100% or say 50% outside air to condition your space. But this is exactly where doing a calculation to figure out what are the trade-offs. What are the trade-offs of continuing to enrich with CO2 to maintain those elevated levels when bringing in outside air? Or what would be the cost benefit of just maintaining 400 parts per million ambient levels when you are in that sort of economizer mode? Could you actually save energy and still be just as productive, or maybe a little less productive, by using that outside air but still meet your productivity targets? Not to mention, by not using CO2 all the time, we can also save energy and greenhouse gases globally. Most carbon dioxide is actually generated by natural gas burning. It's actually a really good way to find a secondary use for those combustion gases used, for other industrial processes. But if we also don't have that demand for CO2 and there's not necessarily that ready supply, then we can do our part globally by reducing greenhouse gas and CO2 emissions by not needing it to enrich our indoor plant environments. All right, so quick recap. The 7 reasons why I recommend having access to outside air for indoor plant environments is: 1, to meet minimum code ventilation requirements. The second reason is if your CO2 enrichment fails open in such a way that the CO2 levels climb and you need to evacuate that CO2 for safety reasons. The third reason is if your CO2 purchases or if your CO2 enrichment system fails closed. So you're not getting the CO2 enrichment that you are expecting, and now you can at least bring in outside air to maintain ambient levels of CO2 in your space so your plants don't starve. The fourth reason is to temporarily ventilate your space for worker productivity. The fifth reason is to temporarily flush your space if you did a chemical spray or a sulfur burn or any other sort of wash down in between crop cycles. The sixth reason to have access to outside air is to burp the room when the lights are off or at night so that your plants can respire and be productive in using their energy and building themselves up with that carbon dioxide, with that glucose that they generated during the photosynthetic process. And the seventh reason is to save energy, to use the outside air when it's cool, when it's dry, to do the primary air conditioning you need in your space, and use outside ambient CO2 levels to keep your plants productive. Thank you for watching, everyone. This has been 7 reasons to have access to outside air with me, Dr. Nadia Saba, president and founder of Dr. Greenhouse. For more information, to learn more about indoor plant environments and greenhouses, please find us on our website at www.drgreenhouse.com. You can also find us on Instagram, Dr. Greenhouse and Dr. Greenhouse Inc., and our Facebook page, and I'm on LinkedIn. All right, have a great day, everyone. Thanks.